Hey everybody, we are here. Let's do this. I'm going to bring down the saturation on my video a little bit. How is everyone doing? Sakura, good to see you here. There we go. Is this contrast? Sure, nothing like making adjustments while live. Let's do that. So if you're here, ask questions. I was doing some adjustments to the lighting. Okay, that's good. We'll work on it. We'll get it all improved. How is everyone doing? We're here to take questions, answer questions. If you have them, let us know. And I might do some 201 if there's no questions. But if you're here, remember how office hours work? If you're here, you ask the questions, we do the work. That's what we do. So let me pull up the 201. But if you're here, ask a question. I take all the questions. And so I know we have one student watching right now. That's right here. Oh, we almost have yes. 320 is almost completed, graded. Yesterday we were talking in class how everything needs to be graded, and we see that assignment 1 is almost graded completely, and they haven't started assignment 2 yet, but this weekend should be, a lot of good grading should get done there. So I'm loading up some 201 as we speak right now, and as we speak, it's getting loaded. How is the chat doing? Chat is doing well. If you're here, feel free to say hi. Mubot is here. How are you doing, Mubot? We're always checking in on Mubot. How are you doing, Mubot? What does Mubot have to tell us? Mubot, I should have some points. Stat201 has points. I have no points. Brian has no points on this channel, but Stat201 does. And I am loading up Homework 5 Quiz 2. This has been a big thing for 201 students, this quiz. Really tough quiz. Even I made some mistakes on it. And we did a good bit of them yesterday. Today I might go in reverse order on this quiz. And we now have the quiz up, but if you're here from any class, let me know, and we will do the questions related to your questions and the class. Here we go, UT Marvel's away now, and let's hop over to the screen. We need to change. It's Wacky Wednesdays, so you know what we have for Wacky Wednesdays. Let's do this. Let's hop over to the main screen here. I've got some Coca-Cola. Grab a drink. Let's do some normal curve. Okay, we are here. I look very colorized. I look very purple and red today. Let me work on that just a real quick moment here. Let's see here. What would do it? Brightness? I don't want to do that. I need like a videographer expert. Hey, look at those graphs. You know it. You know it. Look at this graph. I gotta turn that up. I think I hear it louder than everyone. I gotta take some like lessons in how to do proper opacities and coloring for videos. So there we go. Everything every day. So Sakura, inside info here. Every day, sometimes I like move the camera the tiniest of bit. I need to like tighten the things on the camera, and so every day I move it just the tiniest of bit. So you'll notice the microphone will be at little, like how much you see of this microphone right here, which is on a very long arm. How much you see of this microphone varies from day to day as I just bounce the microphone around. So I need to like take the camera and like lock it in place. That'd be a smart idea. That'd be the smart thing to do. Or just, every day just work with a little different angle on the camera. But with this right here, this question is using the empirical rule. I'm going to zoom in on this really big. Good, that works. You can see it is using the empirical rule because we have the 68, 95, 99.7. You should know those numbers instantaneously. So what we're going to do is we're going to find the right graphic here. The right graphic is going to use 68, 95, 99.7, so they're all correct there. It's going to have the mean at the center, which is 192. That's all correct there. And then it's going to go up and down by 28. So if you look at this distance between these two numbers is not 28. This distance is 28. Each of these should be 28 apart. Like this should go 28 down, 28 down, 28 down. And this one right here is double that amount. So this is not correct. Each movement on the curve of one standard deviation should be a distance of 28. And we notice this right here going from 192 to 164 is 28. So what we're going to do is we are going to snipping tool this, and we're going to use this graphic. We're going to take their graphic and we're going to say, thank you. You have given us the answers to these questions. So let's go ahead and take this graphic right here with snipping tool, and we have it. And you do get scratch paper on the exams, and you do get, for 201, you get scratch paper, and you also get the formula sheet. So awesome news right there. Double checked. I'll make sure to announce that in class tomorrow, but there is scratch paper. There is a formula sheet. I was like 99% certain, but as soon as you put that out in there in the world, then all of a sudden everyone's like, wait, Brian, I mean, if I say it, then people should say Brian said this. So I always, anytime I'm like giving official, like this is something that will happen, I always want to like double, triple check it because, you know, there's always like that one time I say something, then it turns out not to be true. And then I'm like, oh, well, oops. Hey, Nikki, what's happening? We're working on some chapter 5, Nikki. Is there a problem you were wondering about on chapter 5? I just started off with the last question on the quiz out of all 21 possible questions. But feel free to say, here's the one I'm working on, and we'll do that question. Or feel free to ask a topic you want me to review, and I'll go over that, like how to break down the normal curve or when we use normality. Any topic you want, we can go into that topic. You got it. So we see right here what percent of adults have cholesterol levels over 210. And let's go right here. So we're looking over 210. So we actually are going to have to use the applet for this because this would be right here. Now, I'm kind of practicing what this would look like, and I can do some estimates. So the estimate of this area right here is somewhere between 16, because that's what's above that area right there. If you're wondering how I obtained that, 68 is between, 32 is outside, and that leaves 16 on either side. I'll zoom out just a little bit here so I'm not blocking that 16. But I'm able to, since this is 68 right here, there's 32 outside, and I know that this yellow area right here has to be more than 16, and it has to be less than 50. We have asked questions on the test like this in the past, asking you to estimate the area. So I know this area right here has to be more than 16, less than 50. So what I'm going to do is I'm going to go to the David M. Lane applet, our applet that we use to get the exact answers when they're not on the empirical rule. So David M. Lane applet, let's pull that up right over here. And here's the David M. Lane applet. I think it was 192 and 28. And we want to go above 210. So this is where I'll make an error. My graphic looks a lot like it, but I'll make a mistake every once in a while. I'll put in the wrong number, and then everything will go haywire. Let's see here. 192, 28, and above 210. And then if you notice, one thing to look at is if your graphic right here looks a lot like this graphic. Take a look at where I shaded. Look at this graph. And take a look where we shaded here. Looks very identical. 26.02 is the answer. And if your drawing looks a lot like it, you have done it correctly. Let me see if there's questions in the chat. Is the normal curve the only curve we'll be seeing on the exam, or will there be exceptions? Great question, Jenny, right there. The normal curve is the only one we really work with in 201. There are other curves. There's the Poisson, there's the exponential, there's the gamma. There's so many distributions. And so this is a distribution of data. And what's really cool, I'm going to show one of my favorite sites. Matt Bogner. This is a guy who teaches at Cincinnati University. So I'm going to try to go to his site. Here's this. And then let me go over here. Applets. Yes. So this guy, oh, wow. Wow. Is this right? Okay, cool. Let's bring it over here. So this guy right here, let me see what everyone's seeing. So this is kind of a quick aside on this, but really great question, Jenny, right there. This guy right here has a ton of different applets, like the normal curve applet, and that's not the normal, it's the binomial. There's the log normal, and here's the normal. So this guy made his own normal curve applet right here. It's very similar to the David M. Lane one that we're using, and you can enter in the mean and standard deviation. So I could have solved this problem using his applet. See, there's the mean and standard deviation notation, and I can go 210 and I can go above. So he even gives you more decimals. I actually really like his applets, but they're a little less intuitive, more mathy. Like you have to be like, okay, because if you look, it's all in like math symbols. It doesn't say like the mean, the standard deviation. So we found that the David M. Lane is generally better for students. So then the question is the normal curve the only model we will be seeing on the exam? Yes, 100%. To answer that as directly as possible, yes. To go into further details, there are many other distributions. There is the binomial distribution, which is for categorical data for like yes, no responses. And if you look right here, the binomial distribution can be very right skewed, or it'll approximate a normal distribution. And this is, his applet breaks when you put in too high of a number. So I actually knew that and I shouldn't have done that. So it looks normal here, but it can also be right skew. It can be even more right skew if we do like the following. It's a very, very right skew distribution. You don't need to know anything about the binomial. Later on in the semester, we will do things like the chi-squared distribution that has degrees of freedom. This is also a right skew distribution too. So on the exam one, you will only be dealing with the normal curve. Later on in the semester, you will learn about the chi-squared distribution, and you will also learn about the t distribution. I can't Google t because I'll go to so many. The t also has with it degrees of freedom, and the t looks a lot, who in the chat for 100 points, looks a lot like the what curve? The t looks a lot like what curve? What curve does the t look a lot like? Can we go over a possible Canvas quiz question? You bet. Which one do you want to go over? We can do that next year. You got it, Nikki. You got it. I'm trying to think. I might have to pull them up to be like more exact. I did them on the Kahoot. I'm more than happy you're here. You ask the questions. We do the work. Do you know what does this curve look a lot like? What does that one look a lot like? Does that look like any other possible distribution we've seen ever? Does that t curve, the t distribution, does that t curve look a lot? Does the t curve look a lot like the normal curve? Is it a t curve? Normal curve. T curve? Normal curve. Normal curve. You're right, Jenny. Great job right there. Now, I want you to, okay, this is worth 1,000 points for our class right here. You've never heard of the t curve before, right? Who can tell me the percent of area, first person, above a t of 2 on this curve? Now, the t curve has degrees of freedom. We're just doing an advanced question we've never done before. Who knows what area is going to be above a t of 2 on this curve? We will not be covering this on this test, but you might know the answer to this question already. So it looks a lot like normal curve. So maybe we should just go with what we think for the normal curve. And then we'll hop over and do a Canvas quiz question. This is my last little bit on this. I always think it's good to lay foundations for the future. So when you get to the t curve, you're like, well, it's basically the normal curve. Basically, there's some things we'll learn about it that make it different. But since we're doing a t of 2 and we're doing the area above, let's look at what we saw previously. This will be for 201. Yep, this will be for 201 at the end of the semester. So, which is only like 2 months away. I say 2 months and I'm just like, that time flies. So this right here is the end of the semester. And look at this right here. If we put z-scores below this is how it relates to what we're currently learning. And this is actually used in our other classes too. If we go above a z of 2, what area would you expect to be above a z of 2? If we go above a z of 2, now this is very important for our current test, a z-score of 2, what should be above a z-score of 2? This is very important for our current test. So we're on current information right here. Above a z-score of 2 is what percent of the data? Very, very close, Sakura. Great answer right there. 2.5. And you might have a more exact answer. You might have been using the applet. That does seem very close to what the applet. Bingo. Everyone's on the right track right here. And you might be using the applet to get that. That might be the exact answer. Exactly. And watch this. 2.5%. It's exactly what you were saying, but we're doing the T curve. I'll talk about Mr. T and how he says, I pay the fool. And he smashes down the normal curve. The normal curve has with it, actually we need to show the other one. Stat distributions. The normal curve, the T curve, Mr. T comes in, he smashes it down. He says, I pay the fool. And he smashes it down and the T curve just wants to be normal. So that's enough about the T curve. We are using the normal curve. I guess I could have shown things via statdistributions.com, another great site with distributions on it. Let me drop this in the chat. This one just doesn't always carry enough decimals. It'll round things, I think, to 2 decimals. So I found issues with this one when doing my Pearson assignments. So this is a small warning. If it wants more decimals, sometimes statdistributions.com doesn't carry enough decimals, but it has the T, the chi-squared, and the F. So with that, some Canvas content quiz questions, some awesome points in the chat. So we might come back to this here later on, so feel free to ask those, but we do what the people want, and we want right now Canvas content quiz questions. Let's do it. So I'm pulling up one of the Canvas content quiz questions. I'm going to kind of do a variation of it right now. So I'm going to take it, read it, and then do a variation of it. So let's hop over here. And if you're thinking of one that's like, hey, Brian, it kind of asked me to do this, I'll do a similar question. Because I'm going to pick one right here. I need to look at them, lest I do one off the top of my head. It's not relevant. Okay, I got one right here. I'm reading it. What percent of adults have body temperatures higher than this? Okay. And does it want you to use the applet? I think it does. Oh, it tells you that. Okay, I can make a variation of this question pretty easily. Got it. Okay, so here we go. This right here is going to be a variation on a Canvas content quiz question. So let me put that like a big note here so I remember when I put this Variation of Canvas content quiz question. There we go. Okay. So what I'm going to do is I'm going to take a picture of this. I'm going to say students, you'll see it in a second, take a test with a mean of 80 and a standard deviation of 10. I constantly use those numbers, so it's easy to remember. And between a 65 and a 95 is 86% of the students. So let me see if I get a better number with this. Okay, good. Got it. Okay, so here comes your Canvas content quiz question that is going to be a variation on this. Okay. So there's the graphic you would see, and let me write the question. Let me see how chat's doing. I'm building a question right here as we speak. Okay, so the question is going to read the following, and I'll make the text bigger. Students take a test where the distribution is normally distributed with a mean of 80 and a standard deviation of 10. We find that is it between a 64 and a 96 contains 89% of the students. What percent of students score above a 96? Okay, this is very, very similar. Very, very similar. So what should you do? Who knows the steps I usually follow to solve a question like this? What do I usually do to solve a question like this? There's something I always say to do when you see something like this. If you see it's giving you information, I'm immediately going to start doing something right here. And the answer is, look at this graph. That's not the full answer, but I'm going to start doing something with it. Who knows what advice you should give student Brian? Student Brian should do what right now? Who knows? I need some advice to solve this Canvas content quiz question. Boom. Right. Nice job, Jenny. You have been following along excellently. You're totally right. I don't care about spelling. That is the right answer. So I'm going to put 89% right here in Rainbow Pen because Rainbow Pen's the best. Sorry. Okay, Space Pen. I'm sorry. I'm going to put the 96 down below here so I can see it. I'm going to put the 64 down below here. If you notice, this is a symmetric area. So since this is symmetric, we know that the area is outside of it. Oh my gosh, you got it, Connor. Great job. Good to see you here, Connor. I saw Seaver sent an announcement about white noise. There should be a test for that. I mean, like inside of orange stuff. So great work. People are working really hard at stuff, and so good to see you here. Who knows what's going to be total outside? Total outside. Total outside is what? Total outside is what? Total outside. Like both hands. Both hands is worth what? The box test NAR? Is it box? George Box's famous statistician. Close. Remember, look at the bingo, 11%. It's 11% because it's the remainder of the outside. Does that make sense right there, Nikki? Do you see how we're getting 11%? Because 89% inside, 11% outside. So since the middle is, wonder who that other person is. Wonder what they did in stats. I don't know them. So Nikki, what is one of these arrows worth? What is like one of these arrows right here is worth how much now? One of these arrows is worth how much? Just one of these arrows. Bingo. Nice job. 100 points, Nikki, and 100 points, Connor, and 100 points, Jenny right there. Amazing work. Exactly right. That's the answer. The answer is that it is 5.5%. This is very similar to Canvas content, a Canvas content quiz question that shows you, and this kind of shows you how we'll do a test question. We might show you a graphic like this. And now let's ask another question. Let's go here and say, so the answer to this one was 5.5. Let me highlight that right here. If you're wondering, the answer was 5.5. So the answer is 5.5%. Let's do a very similar question right here. What percent scored above an 64? What percent scored above and 64? Oh, really? I'll have to look at that. I need to like watch all of Seaver's lectures. I need to. So here's the best thing to do. Whenever you see this, always draw out, and I wish I could highlight the middle of it, but I'm gonna draw like a mini version of this down below it to show what we want to do. So here's my mini version. No, don't worry. 100 points. Keep following along. Keep working. Like don't worry. Wrong answers get you to right answers. Don't worry about it. The worst thing to do is to like not say a wrong answer and then just be like, I have no idea how to do it. But look at this right here. Just when you look at this, boom, look at that. You see it now. You're like, okay, I need to, you see it because you're like, I need to add up the number here, which is 5.5, and I need to add the number here, which is 89, and then you see it. You're like, okay, that's what I'm doing right now. I'm going above that line. Exactly, Nikki, 100 points right there. And Jenny, great job. This is the practice we need. We just need to like, it's just the more you do it, you're just like, okay, I get it. It's seriously like playing an instrument, because like if someone asks you to play a scale and you know how to play an instrument, you're like, well, duh, just go like C, D, E, F, G, A, B, C, C. I can't say the word note, can't say the notes backwards. And so the more you do it, like you're just like, well, you just do it. But then if someone said, well, how'd you learn it? You're like, I don't know, I just did it a whole bunch of times. So it gets easier and easier as you do it. The more you do it, the more you're like, well, I understand it. So another practice. Should we do another Canvas content quiz question? Sarah did not suggest if you wanted us to manually compute the Q test. I was like, I can do it. Because you can do a system time on that. I was thinking about writing, if 474 came here, I was going to write some things to solve 201 problems in R. And I was going to make a thing that just solves, like all you do is put in the numbers and it solves everything. I was going to write a function that tells you like the area above, below. And it's just like, here's the area above, here's the area below. And you could put in a vector on it. Random call from Knoxville. Well, hopefully they leave a message if they're actually so unreal. Who's noticed, along with me, that every call you get now, if you don't know the number, is just some telemarketer or something, you know, like, hi, your auto insurance is about to expire. And you're like, yeah, I don't care about that. So here, I'm going to come up with another hard Canvas content quiz question. Possible Canvas content quiz question. Who knows? I'm just looking at them and thinking, how could I turn this into a question? So let's go here and yeah, it's actually, yeah, why not? That's very similar. Okay, we're working with the same type of, no, let's make this really hard. Yeah, sure, why not? Okay, so this right here, it's not that hard. I mean, I say that and everyone's like, ah! So I'm writing a second Canvas content quiz question right here, Canvas content. And let's try to do this one right here. This is one of the harder ones I could write. So if you are following along with this question, you are doing exceedingly well. It's about the hardest questions we could write. Canvas content quiz question 2. And just putting that there for note for myself. Once again, the test is normally distributed with a mean of 80 and a standard deviation of 10. The following shows the z-scores of, is it 1.842, I think. Wow, I've seen that so many times. Of negative 0.842 and 0.842. What was the score, which represents the middle 60%? What was the score of the, just double checking, 80th percentile? Okay, harder question right here. Let's see what we should do. Who's got some advice to start out? Once again, Brian needs advice again. Who's got advice? Did you take my, wait, what? Oh, you scared me right there. I read the second message first, Connor. I was like, what? Anytime I see that acronym or that abbreviation, I'm like, what's going on? What's going on? No, they do that. They'll say like, there's been, yeah, I know. I just saw, I see, at first I read, did you take my son? And I was like, did you take my son? I was like, what's going on? Yeah, I think they know how to scare people. They say stuff like that, and it's like, you're like, oh, I better check this. What if I'm wrong? One of our family friends got scammed because they told her, I think they might have gotten her social. They'll do just, if I don't know who you are on the phone, I'm not talking to you. If you're like, I'm calling with the census, I'm like, too bad, I don't know who you are. Anyone could say that. So I don't know. We live in interesting times. People used to, talk to telemarketers all the time on the phone, but I don't know who you are. I don't know what you want. And anyways, psychology says if you start talking, they'll usually put the questions you don't want to answer at the end, like just psychologically speaking. So yeah. What should we do? Brian needs help to solve this Canvas content quiz question 2. What should we do? Write the percentages. Nice job, Jenny. Excellent work right there. So we're going to take the percentages. So remember, always start out. This is great advice right here. We always just pause. And this is why I asked the question. Don't worry, Nikki, you got this. What do? We write the percentages. So let's go ahead and write the percentages on here. And we're going to write 60% right here. And then we're going to put here 20%. Rainbow pen? Oh, I think, is Word crashed. That's what we do. Are we still broadcasting? Give me some yeses. We're still broadcasting because Word is crashed, which is odd. I don't like when Word crashes. I know. What is going on? Rainbow pen just stopped working, and then the Word crashed. Well, let's see. Okay, is this? Okay, Word is just completely crashed. Close all windows. Close the program. Let's hop over to this screen right here. Let's put up Marvel. Let's try to bring it back into Word. Okay, it's back. Whoa. That's just weird. I don't like weird. There we go. Okay, we're back. Do we have that document? Okay. I don't know if Rainbow Pen crashes Word. Okay, how much are each of these arrows worth? Oh, so weird. How much is each of those Rainbow Pen arrows worth? How much is each of those Rainbow Pen arrows worth? 20%. Sakura, great job. That's worth 100 points. Thank you for helping out with these. And if you have questions, you can ask. Don't worry. We try to hop around material. And so it's 20% because, remember, 60 inside, like always do it slowly. 60 inside, 40 outside. Each of my hands is worth 20. Does that make sense? Anytime you see like this inside-outside thing, always be like 60 inside, 40 outside, and then divide it by 2. So it's, you take whatever's on the inside, subtract that from 100, so that's 40, and then you divide it by 2. And the reason we're able to do this is due to the symmetry of this. There is a symmetric line right here. We're going symmetrically up and down. So because of the symmetry, which is key here, you can't always cut an area in half. Like, to be very clear, you could not cut this area in half right here. Like if this was a hypothetical area, you could not cut this area in half. Imagine this is a slice of pizza and I cut it in half right here. How would you feel if I said, yeah, I'll give you half my slice of pizza? I mean, I'm going to eat the crust though, it looks like, but you get slice B. So can you cut this area in half and just be like, oh, that slice of pizza, and cut it in half right there? You wouldn't really be cutting the pizza in half. You would be giving the person a smaller half, which a totally different portion. But this area over here, if you notice A versus B, that's the highlighter. This area over here, we can do symmetric cuts on because it's down the middle of the curve. So A and B are worth the same amount. A and B are worth 30. So if you really want to break it down further, which we've done some drawings, you could go, oh no, okay, good. It's I can't erase the things that were already there. Oh, that's so weird. It's like an image. That's worth 30 and that's worth 30. Can't erase the 60. It's there forever now. So with this right here, we see the curve fully broken down. And what do you notice on here? Do you see a number we could maybe mark along the bottom? What could we mark along the bottom? Like, what might we put here? Who's got numbers we could put there and there? I mean, there's maybe let's put some percentages there. Rainbow pen is forever. Rainbow pen's never going away. Space pen versus rainbow pen. That gives me ideas. Close. So think about this. If we go along here, how much percentage will we have added up to here? If we go along to right here, well, oh, I see what you're saying, Nikki. Actually, you are right. Nikki, let me not correct you. Nikki's saying 70 here and 90 here. These are actually really good answers. Nikki, 100 points. This is going to give us some really good advice right here when we get to estimating our answer. Now, estimating is just a good way of guessing at it. And Connor adds some additional advice that right here is where 0.842 is at. And right here, and these are in terms of z-scores, and this is negative 0.842. Does this make sense to everybody? Does everyone understand what you're seeing right now? We've done a lot of drawings and we're pretty much right at the answer. Because can you just guess where the 80th percentile is? The 80th percentile is going to be right here because you'll have gone through 20% and through 60%, and that's the 80th percentile. And this is where we'll get the exact answer. So this is right here, the 80th percentile. Does that make sense? That's the 80th percentile. That's where the 80th percentile is. Not where 80 is out on the curve, but that's the 80th percentile because 20% is above it. So I want you to tell me what the z-score means right here. The 80th percentile is what? Tell me what the z-score means. The 80th percentile is this. The 80th percentile is this. Tell me what the z-score means. The 80th percentile is this. Who can interpret the z-score? The 80th percentile is... You have to interpret the z-score. A good practice on z-score interpretation. The 80th percentile would be students who scored. So here, I'm going to give you blanks. The 80th percentile would be students who scored this much to the mean. So the 80th percentile, if you interpret what the z-score means, it'd be students who scored this much above the mean. Does that make sense? And I'll show a quick example right here. Like my height is in the 97th percentile of heights. I always use the height example right here because the average height for guys is 69 inches. And then you've got here 72, 75. So it's really easy to see right here. Brian is how many standard deviations above the mean? So Brian is how many standard deviations above the mean? It's good to see you here, Nicholas. We haven't, you've been, I don't remember who's like new and old. Brian is how many standard deviations above the mean? Brian is 2 standard deviations above the mean. Does that make sense? So think about what you would do if I told you, like, solve this right here. Solve using 2, solve for Brian's heights with these numbers. With 2, solve, show me the mathematics. Oh man, MuBot's awesome. Using 2, use these numbers to solve for Brian's height. Using 2, use these numbers right here to solve for Brian's height. Remember, Brian is 2 standard deviations above the mean. So using those numbers right there, solve for Brian's height. Like, show me the mathematics. Show me the mathematics. Who knows the mathematics to solve for Brian's height? Show me how we would solve mathematics on that. Do math. Everyone's like, no, I don't want to do math. I'd rather have Coca-Cola. Solve this problem for Brian's height. Little bits. Little bits. You know, if you say one of the things on the soundboard, I got to play it. I need to get oof today. I need to do that after class, after office hours. How would you use these numbers? Well, okay, wait, think about this real quick. Here's the answer. Here's what we're doing to solve for Brian's height. We got this. This is good practice. Here's what we're doing right here. Can you write this as a mathematical formula? Think about what you're doing. You're going 2 standard deviations above the mean. So you're taking the mean and you're adding to it 2 standard deviations. So just wait, are you listening? Right? We're taking the mean. That's the first thing you write. And then we're adding to it 2 standard deviations. Does that make sense right there? We're taking the mean, which is right here at the center, and then we're adding to it 2 standard deviations, and that'll give us the answer for Brian's height right here. Are you with me on that? Can you see it right there that we take the mean and we go up that many standard deviations? And it'll be 75. Great job right there, Jenny. Excellent work. So think about what we need to do here. What should I start out with to figure out the observation for this graphic up here? I should take the what for this graphic first. Using the same methodology, what should I take for this graphic up here? I should take the what to start out with. I should take the what to start out with. Use the same methodology. The mean, great job, Jenny, right there. We're going to take the mean. So we take the mean, which is 80. Then we're going to add to it, and we're going to do the z-score. Because remember before I said 2, because I'm 2 standard deviations, that was the z-score. So then we're going to take the z-score, and that's 0.842. And that the z-score tells us how many what's we will go up. The z-score tells us how many what's we will go up. The z-score tells us how many what's we will go up. So we're going to take to it the mean and add to it this many worth of z-scores of the what's we will go up. Bingo, Jenny. Great job, Jenny. You got this. That's how many standard deviations we get, and that's the observation. So if you look at the math, I was really nice with this 10 right here because the answer is going to be 88.42. Because if you solve the mathematics, this is what you'll get. Does this spot right here on this curve, does that look like it could be at 88.42? Does right here look like it could be at 88.42? Does that seem logical? Yep. Oh, someone was wondering, how did you get the, yeah, good question right there. It's in the initial question. Great job. Jenny, thank you so much. And Nikki, great work right here. Good practice. This is probably one of the hardest questions we can write on the test. I mean, you can take it, there's only one level higher I could go on this where I don't give you a certain number, but these are some of the hardest questions we can write, and knowing how to take a z-score and turn it back into an observation is important. Does everyone see if you take the z-score and times it by the standard deviation, you can add it to the mean? 10 is in the initial question. Good question right there. 10 is part of it's the standard deviation right here, and that's where we did the 80, 90, 100, 110. And so just kind of seeing the full question right here. I think let me go out of the way a little bit more. Let me just vanish. We need Brian Jr. Where's Brian Jr. at? That's not Brian Jr. That's Brawl. 320 knows what I'm talking about. There we go. Here's Brian Jr. So right here is the equation we're using to solve for the answer. And we have everything, Brawl. And so we have everything right here. I had the wrong Brian out. It was actually Mirror Brian. So many Brians on the screen. I know you're welcome, Jenny. What questions do people have right now? You can say do another Canvas content quiz question. That was our second example of a Canvas content quiz type question. But it's your call. It's your office hours. This is your chance to say, hey, Brian, I'm stuck on this. I don't understand this. Can you explain further? That's the wrong me. I gotta be me. That was the worst I gotta be me ever. So who has additional questions? So it's locked. That's why I can't move it. Who has additional questions? Say, hey, Morgan, can you go over some of the homework problems involving the website you use? Of course. We were doing some of that at the start right here. Thank you, Morgan, for swinging by and asking for the question right here. And if I'm ever teaching something, you can ask the question while I'm doing it, and then we will do it next. So if you're ever like, oh, Brian's doing a question, just be like, I have a question. So this is one of the possible Canvas content quiz, or one of the, you're welcome, Morgan. And then we can do that next. Sakura, you got it. So we go right here and we see that we have the normal curve already made for us. The first thing you want to identify for a question like this is, one, does it have 68, 95, 99.7? Does it have these numbers? We used to scream these at the top of our lungs in the Haslam building in the good old days, the before times. But this has 68, 95, 99.7, which is the area between 1 and -1, -2 and 2, and 3 and -3. When you go out, 68, 95, 99.7. So with this right here, we also need to check to make sure the mean is the right mean. The mean is 192, and you see right here, 192. Oh, sorry, Morgan. I know. I like it in person too. But we try. We do our best with the online. We do it. We get online working. And 192 is at the center. And then what's the only other thing I need to check to make sure that these are proper underneath the distribution? So I checked to make sure the mean is correct. I checked the percentages. I checked the mean. And now I need to check that each one of the blanks is accurate. What should I check next with this to make sure each one of these is a certain amount of something? What else should I check? I checked the percentages. I checked the mean is at the center. Standard deviation, Morgan, great job right there, 100 points. We're making sure that this goes up by 28 each time. If you look right here, each one of these is up by 28. The wrong answers will do different things. Like different questions have different wrong answers. But if you check the percentages, if you check the mean, if you check the standard deviation, all of those are accurate. You've done it. That's really all they can change on these. So what I'm going to do once I see this graphic is I'm immediately going to go over to the David M. Lane website. So the best way to do these problems is when you get over here, take your numbers 192 and 28 and put them here and put them here. So on this one, put 28, don't put the wrong answers. So on this one, you have to put them here for the mean and this for the standard deviation. And on this one, you put it here for the mean and here for the standard deviation, just where it says it. Make sure you put them in the right spots. Put them in the wrong spots, problems are going to be wrong. So the difference between these, because we're looking at what is the data, what kind of context, cholesterol levels. Okay, so every question right here for this first button would be questions like, what percent of adults have cholesterol levels above 200? What percent of adults have cholesterols below 180? What percent of adults have cholesterols between 120 and 160? Does everyone hear what I'm starting every question with? Who can tell me for 100 points? Every question for this is basically going to ask what? And let me repeat and put it in the chat. But the top one right here that we're looking at when you're solving using this, boom, every question is going to ask for a percent because that's what we get returned. We find out the area under this curve. So any question that says like what percent of students will be above this height, or what percent of IQs, or what percent of steer weights, anything that asks like that wants you to return a percentage is going to use this. Now here's the, if it asks about percentage, it doesn't mean use this one. You could say, where is this percentage? So this graphic right here will return a number. Like when we say, where is the 80th percentile? If I asked, what is the 80th percentile? This one right here will tell us where is the 80th percentile, not how much a percent is. So let's be careful right here. Just to be very clear, on this one, you use points on the curve to tell you the area. On this one, you use an area to tell you the points on a curve. So questions that ask you what percent would be this one. Questions that ask you where a percent is this one, because then you'll get a point. Like this is where the 80th percentile is, and we return a position on the curve. Is this making sense to everybody? I know it sounds very similar. So this area right here represents, and so if I interpret this, using the normal model here, we would expect 80% of adults to have cholesterol levels below 215.56. And also this is the 80th percentile. So as in the top 20% of adults, does everyone see how there's 80% graphed? So 80% right here, there's 20% above it and 80% below it. So the top 20%, so the areas that it can be, good question right there, Morgan. When you graph below it, it's the percentile. So what if I were to do this right here? What percentile am I showing right here? This is a really good question. What percentile am I showing on the curve right now? What percentile is Brian showing on the curve right now? We're going to do a slightly easy question and then a little harder. The 90th, you are correct. The top 10% is the 90th percentile. Now let's make it a little more difficult. Let's say, what percentile am I showing right here? Be careful. This is one of the tougher questions if we put this on the test. Once again, if you draw on this, it makes it a lot easier. So we'll see if people get in, then maybe I'll draw on it because someone might be watching this later and be like, how did you figure that out? What percentile is right here? So let's draw on it. You ready? So how much are these two shaded areas worth total? Dorian, this is good because I think I know what you're doing, Morgan. Like that was a good guess right there. 100 points, Morgan. Good guess. So total, these are worth 10%, right? So we know the total area right there is 10%. I'm even going to grab this just so we can see it. Let's go over here to a new page, and I bet you'll. So just knowing that that is the total area shaded. Yes, Soccer, great job right there, 100 points. That is correct, and this will come in use in 320 a little bit too. The total areas right here is 10%. That makes this 5% right here, and that makes this 5%, and that makes this 90. That means if we go all the way to here, we've gone to the 95th percentile. Does that make sense right there? Does that make sense, Morgan? That total being shaded now is 10%, meaning there's 5% on either side, and that's the top 5%. So this is about as hard as a question could get, and drawing on it can hopefully show. Yeah. If you are getting this and you could do this instantaneously, you're at the upper level of understanding of like how we can show pictures and knowing that that's the 95th percentile. And usually just drawing on this helps it out to make more sense. Great job, everybody. A lot of hard work today. Please ask questions. I might be holding even more office hours. I just try to like utilize as much time as I can to help everybody. I hop off and I answer emails. I go to Discord and everything. So please message me. Please ask. Here to help. I answer all emails before I go to sleep. I answer all emails when I wake up. During the day, I try to keep up with the emails and don't be like, oh, Brian gets so many emails. Don't worry. I get so bummed when a student's like, Brian, I know you get so many emails. I'm like, don't worry about it. That's my job. That's what I do. If students stopped emailing me, I wouldn't have a job. So the day students stop emailing me and UT's like, yeah, Brian, we don't need you anymore. That's the sad day. The day I have so many emails, I'm like running to keep up with them. I'm like, yes, I am needed. People are utilizing what we're doing. Enough about me, more about you. Let's do this. Let's see right here. So, we've got all the Canvas content quiz questions, right? Or we've got all the My Pearson questions ready to go. So let's take a look. This one wants, what percent of adults do you expect to have cholesterol levels over 210? And I did this one early on in the video. So you can see where I went here and I went to above 210. And so above 210, we need to click the buttons. It didn't change the graphic yet. Above 210 is this area right here. That's where I obtained the answer from. We'll do one more of these and we're going to jump to Sakharab's question. Now, this one right here says between 150 and 170. Should I use the top or the bottom button? It says it gives me the numbers and it wants the percent of adults. It wants me to find the percentage. So it wants me to find the area and it wants between 150 and 170. So it wants me to find the percentage. Should I use the top button or the bottom button? Which one returns percentages from values? The top button or the bottom button? Which one of these will give me a percentage to end? And you can kind of see down there at the answers. Which one of these, the top or the bottom button, will give me a percentage to end the answer? Like I can say between these positions on the curve. The top, Morgan, great job, another 100 points. Getting all the points during office hours. Try to give out points during office hours. The whole point is you're meant to get the points during the week. So that's 14.92. So I don't mind giving out tons of points. I want people to learn, interact, get points. Now this one really stumps people because it's the IQR. And I used to do this one in such a convoluted way. I used to do this one in such a ridiculous way. But the IQR is the what percent. You should notice instantaneously that the IQR, and we'll do a drawing right here to help us remember, that the IQR is the what percent. As people are trying to answer here in the chat for another 100 points, the IQR, think of quarters and think of interquarters. The IQR, which is represented by the box in a box plot, the median's in the middle. It's part of the it's an extension of the 5-number summary. A good review of 5-number summary on the screen currently. The IQR is the what. And so we know it is it's right here. It exists in this region, and it takes up this area. Or it consists of this much of the data, I should say. So it exists in this area, and it's a range. IQR stands for inter, which means middle, and then quartiles, which means these things right here, the quarters of the data, and there's 2 of them, so that's 50% in the middle, and the range. And so when you think about range, the full range of the data is max minus min. So when you do the range, you do max minus min, which is big number minus small number. When you do the IQR, it's just big number minus small number. So if you think about like memorizing the formula, which it doesn't hurt to do. If you do it in reverse, it's just a negative number. So just a range, it's distance. And so all you're doing is taking big number minus small number, and you're treating the middle 50% like it's the extension of the data. So you're finding out the range of the middle 50% of the data. So that's what the IQR is. And now we need to do it graphically right here. Well, it told us the percent. And there we go. And that'll work, or this will work, because the outer 50 and the inner 50 will both show the middle 50. If you look at this right here, just to show you, it's just doing the same thing. And now we have it. So what do we do formulaically? We take big number minus small number. And outside inside work, both numbers are going to be the same right here. It's still just the outer 50, the inner 50 still does the middle 50 and puts lines right there. So both work. And it wants the IQR. We've done it. 38 to 0 to the nearest integer. Above what value are the highest 15% of adults? It's now given me the top 15%. Should we end with a guess? Let's see if we would have gotten it correct. The highest 15% is right around the highest 16%. So I'm going to say 221. Round to the nearest integer. You got to have faith. You got to have faith. You ready? Can we not check answers? What did I do? Oh, I didn't select the graphic. That is the right graphic, right? We guessed that. We guessed it. So if I get this wrong, I'm too afraid. I don't want people to think Brian doesn't know how to do this. Brian, should I have had faith? Should I have had faith? I got it to up to 0.02, which it doesn't ask us for the remaining decimals. Unless we've made a mistake on the other ones, 2 decimals, 2 decimals. Always check your decimals with my Pearson. check answer. You got to have faith. Why didn't I click it? We would have gotten it right. We wouldn't have used the applet. And if you're wondering, how did I know that? You got to believe. You just got to believe. Come on, Brian. If you're wondering, how did I know that? Think about where the top 16% is. Where is the top 16%? According to the empirical rule, where would the top 16% be? According to the empirical rule, where would the top 16% on this curve be? According to the empirical rule, where is the top 16%? Brawl's got all the confidence. I should have brought up Brawl. He would have clicked that for certain. He'd have been like, well, no duh. I'm like, Brawl. Brawl has too much. That's who taught class when I was getting everything wrong. I felt so bad. Like, I made like just a few random mistakes and then it just compiled. And I was like, someone's gonna be like, do you know how to do this? That is the most hurtful thing a student's ever said. It happened early in my career. I think I told that story when I got a few things wrong. And then they looked at me and they're like, do you even know how to do this? And I was like, oh my God. It's so easy to make mistakes. It's so easy in coding. And it's just, if you make a mistake, you start to second guess yourself and you start to do things too quickly and they just start compounding. And if you look at this graphic right here, what am I drawing? I'm drawing right here that we are trying to find the top 15%, which is where, it looks like I'm showing that Space Pen does that. This is the top 15% right here. And the other one is the top 16%. And the top 16%, according to the empirical rule, would be at 220. So this is at 220. And our Space Pen one is at 221 because it's the top 15%. So it's just right above the top 16. And just to confirm this via my Pearson, we'll do one more my Pearson question here, and then you got it, Soccer. We'll do your next one. The top 16%, he's got to have faith, right? 220. And let's see how close it is to 220. Boom, rounds up to 220. So you can do a lot of different answers kind of in your head. Since it wanted me to round, I was like, I should have done it. I just figured out, I don't know, it's so easy to mistype a decimal. It's so easy to round incorrectly on these. Please email me if you round incorrectly. I've given points back. People are like, hey, Brian, I rounded incorrectly, and I'll give points back. Okay, we got one more. Did Morgan and anyone else, is there a specific problem you're working on this assignment? Like you can say like the IQ problem, the steer weight problem, the rivet problem. There's multiple steer problems. What else is there? There's the downhill skiing problem. You can just be like, yeah, that one, and just make sure to tell me which one. What else is there? There's the football player problem. We've done a lot of these before, but if you're working on a specific one, I'll do it right now in the video and I'll explain how to do it. What else is there? I'm trying to think what other problems there are. I might just find one, but be like the IQ one or whatever. There's different IQ ones that do like percentages or do like, but hopefully this has helped a lot. Like once you know how to solve these, weight of steers with 58th percentile, you got it. I think that's, watch, this is going to be sad. Question 5. No. It's the first one, the homework. Can you tell me a little bit about it? Can you tell me a little? I think this is it right here. This is another version of it. Okay. So is this class only an hour? No, we're going to be online on, we're going to be here till 2, or wait, your time 3. Haha, not that I'm an hour behind. 2 hours today. 2 hours today, Nikki. So keep asking questions. And Mallory, weight of steers with 58th percentile. So this should look does this look like your question, Mallory, right here? Does this look like the one you're currently working on? Because what we're going to do first is we're going to take these numbers and put them into the applet. So we're going to take 118873 and put in the applet. Awesome. So we're going to go over here to the applet, and applet's on that screen. Do I only have it on that screen? Well, I guess I do. No, wait. 11, and make sure to enter these in the right way. 118873, double check your numbers. If you enter them in the wrong way, 118873, 118873. Now, whenever you do percentiles, it's important to note that percentiles always shade to the left. Can we go over another canvas, go into like the one? Yeah, let's do that. We'll do that next here, and then we're going to go to Socrates' question next. You got it. So we'll do another canvas content quiz. We'll do another really hard canvas content quiz. Okay, so every time you do percentiles, do I want to shade to the left, the right, the middle, or what? What is the easiest way to do percentiles? Left shading, right shading, or middle shading? So let's see here. Let's type in 80. Should I shade below it, above it, to the left? Yep, and that's right here. Now I could get the 80th percentile. Watch where this line is at. Just watch that line. Don't watch as I go here, and watch that line. Same spot. So the top 20% is the 80th percentile. So you can show it this way. You could also do weird things like watch that line, only watch that line, just watch that line right there, that line right there, and you'll notice it's in the same spot. So this is still the top 20%. That is still the 80th percentile, because inside of here is 40, and then outside of here is 60. Oh, wait a minute, do I have an error? No, outside here is 40. So this is 20%, this is 20%, as in this is the top 20%, and below here would be 80%. Inside of here is 60. Even I make mistakes, so it's possible. Yeah, I'm trying to, it's similar, Nikki, and definitely watch the videos. An 80 is a good grade on this one. Still trying to make the hundreds. You got 2 attempts and try to make the 100 on it. And so if we're doing percentiles, the easiest way to graph them, if you think the question counted you wrong, tell me. Let's show it right here. The easiest way to display them is going to be the below percent. So the easiest way to display percentiles is to do the area to the left of it. And let's go back to our question. Let's do the following. I'm going to shrink this down so I can show it at the same time. And here we go here. What did I do? Oh, that's what happened. That's not good. Okay, cool. And sure. Okay, let's get the 7. Okay, here's what I want people to do. I'm going to solve all of these, and I want you to type these answers in the chat as I do them. Got it? Or I can type them. So here we're going to find the 70th percentile right here. I might just copy paste it in the chat. The 70th percentile is this one right here. That's the answer to the first question. It's just if I click there, it'll go away. The 99th percentile is going to be all the way about, wait a minute, I know where it's at. It's going to be right about here, 2.3263. So right there. That's pretty close. So that's the 99th percentile on the curve, and it's the answer right here because we're graphing the area to the left. That's the 99th. And then it wants the IQR for the weights of steers. Once again, the IQR is the middle 50%, so we need to go between, and we could do it by finding Q3 and Q1, but these are the 2 numbers we need to subtract here. So we're going to pull out the calculator, and we are going to show it on the screen right here. And with the calculator, we are going to do Q3, which is the 75th percentile, 1237.23, got it, minus Q1. So we're just taking the 2 percentiles on the normal curves, the 75th and the 25th, subtracting them, and that right there is the IQR, the distance between the 75th and the 25th. Now that we have the answers, we can go over here, and it says round to the nearest whole number. So 1226, 13, I can't type, 1358, round to the nearest whole number, 98. If I could type, literally can't type. Yes, we've done it. We're on a roll today. Not today, my Pearson. That's what we say to my Pearson, not today. Is this making a little bit more sense here, Morgan, on how to do these using the applet? So I just went through and did all 3 of them by solving the answers in the applets and finding the IQR, which is the middle 50, and subtracting these 2 numbers to get the distance between those numbers is 98. How does that look right there? And then we're going to do another Canvas content quiz, and then we're going to do question 2 for 320. All this good stuff right here. Let's see. Let's come up with another Canvas content quiz. Let me look at them to see if there's anything I feel that hasn't been completely covered. And will you go back and look at my quiz? I think most of the questions I got wrong was because of rounding issues. Yes, send me an email, Mallory, to remind me. And so, you know, bstevens@utk.edu, and then stat201, your initials, all that good stuff. Send me the email, and it will remind me, because I'll forget if you don't send me the email. You'll be like, just remember. And I'll be like, yeah, my mind will forget. I will not remember. So I've got another thing. I need to put that. I'm going to put a reminder on my phone right now. Remind me at 5 p.m. tonight to change due dates. Okay. There we go. I have to change some due dates for 201, and that's going to remind, all of a sudden at 5 p.m. I'll be like, what? Oh, yeah. Because I was going to do it earlier, and I was replying to emails. So there's going to be, we're going to move the due dates around a little bit in 201. I've already moved the visualization that was due the middle of this week. It's nothing that's hitting, like the project's still due on Friday, and but we got the email yesterday to move it, and I should have just done when I looked at the email, but I was like, I'll do this in a moment, and then I was replying to everything else. So the finishing times, blah, 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 are normally distributed. Okay, wait, so there's an easy one on here. Find a z-score, that's not that hard. Well, I do want to point out, standard deviation of 3, use the empirical rule. Okay. Let's do some other questions, because I am seeing mistakes on these when I look at people's Canvas content quizzes. So let's do 3 not so tough questions for the test Oh, what's up, David? Good to see you here. The question involving the 53 skiers. Yeah, we'll do that. Yep. And so, Morgan, we got that next here. Here are 3 questions that could be on the Canvas content quiz that I don't think are the toughest of questions, but when you know how to do them, they're really easy. So let's do these 3 questions right here. Let's do it. So runners of a race have their times, which are normally distributed. I don't do grammar. The race takes 240 seconds on average with a standard deviation of 30 seconds. What percent of runners do you expect? Let's do this. Question A. What percent of runners do you expect to take longer than 300 seconds? What percent of runners do you expect to take longer than 180 seconds? What percent of runners do you expect to, nice answers, between 180 and, okay, let's say this. Use the empirical rule. 68, 95, 99.7. Okay. First thing I'm going to do on the test right here, which I always beg of people to do, and I'll be putting out videos on this. First thing is I'm like, you have to draw out the normal curve. Draw the normal curve. Find your pen wherever it exists. Draw the normal curve. And let's do this right here. So we take our pen, we draw the normal curve, and we do the following. We put on the normal curve 2 things. Always put on the normal curve 2 things. Here's the 2 things we put on the normal curve. We put on it the actual times, which was a mean of 210. The question told us this. Did I say 210? I think it was 240. It is 240. So the question told us the distribution is normally distributed with a mean of 240 and a standard deviation of 30. That means every time I go up a certain amount of units, it'll be 30 up. So every time I go here, it'll be a unit of 30. So watch as we do this right now and we draw 3 standard deviations up, because that's what the normal curve generally encompasses. There are standard deviations outside of 3, but this is 99.7% of the area. Great job right there, David. David, 100 points. Feel free to drop those answers. You are correct, and you are getting review practice because this does come into play for other classes. The normal curve does not go away. It's a very, we call it the normal curve for a reason. It's on the Deutschmark for a reason. It's a very, very common distribution. And my curve is probably not sloped enough. It needs to have tighter slopes at the end. But if you notice right here, all of the questions we're working on can be answered with this. Now, don't just stop here, though. Down below this, you should put your z-scores. So we put the z-scores right here. And this is going to be a huge help. The z-scores right here are going to be a huge help in helping us understand. Now, if you want to go the extra mile, and it's not a bad idea, you could right now just draw the percentages on the normal curve with 68, 95, and 99.7. So if you take a moment on the test with your scratch paper to draw this out, you'll be pretty good. Now we're going to do one last thing here. This is the last thing I would draw if I'm going to draw my super normal curve to prepare for the test. I'm going to draw the percentages outside. I need people to tell me what is the total outside of 68, because I get this wrong every once in a while. What is the total outside of 68? Who knows the total outside of 68? If we have 68 on the inside, what's total outside of 68? What is total outside of 68? What is total outside of 68 as I draw the rest of the arrows? If 68 is on the inside, then total outside. 68 inside, total outside is what? 32. Nice job, Morgan, right there. That makes each of these worth 16. So Morgan said there's 32 total, and all we're going to do, nice job, Nikki, it's going to be 16 for each of these arrows. And now we go here, and 95 inside, 5% outside. Each of my hands worth 2.5. And then one thing I want to point out, if you're wondering about your numbers, if you go across these arrows, if you go across this, it should always add up to 100. If you follow this like it's a pathway, you should always get to 100 because you've covered the whole curve. Because this 16 represents the area below here, the 68 is the area between here, and then the 16 is the area above here, just like this is 2.5% of the curve, this is 2.5, and this is the middle 95 right here. So you can check your curve as you do this to make sure you've put in the right numbers. 99.7 inside, subtract from 100, 0.3 outside, cut that in half, 0.15 on either side. So this is 0.15. So we've done it. And these extend throughout. Like it's not between 3 and 4, it's from 3 to infinity. So I guess we should say like this right here goes from 3 beyond, and this goes below right here. So very important you don't think it stops at 3. Okay, so now that we have this, we can answer every question pretty easily. We took a moment right here and we drew it out. What percent of runners do you expect to take longer than 300 seconds? Who knows the answer to the first one? What percent of runners do you expect to take longer than 300 seconds? This is question A we're doing. Question A has been answered. Who knows in the chat? What percent of runners do you expect to take longer than 300 seconds? Be careful. Nikki, 100 points, but what should it be? Longer than 300 seconds is going to be what percent? 2.5, yep. Great job, Morgan and Nikki, another 100 points. Getting your 500 points during office hours review today. And you can see it right here. Just draw it out and then check your answers above. Make sure you just like draw it out. Be very careful. It's a z-score of 2, and we can see that right here with our drawing that it's a z-score of 2, 95% inside, 5% outside, 2.5 on either hand. Next, we have a question of what percent of runners do we expect to take longer than 180? So what percent of runners do you expect to take longer than 180? Who knows in the chat right now? Longer than 180 should be what? This is going to take me a while to do this right here. Longer than 180 should be what? Longer than 180 should be what? What percent of runners do we expect to take longer than 180? And here's the hint. It's not the shaded area. Maybe I shouldn't have done that because it looks like we're talking about the shaded area. But the shaded area plus the other area is 100%. So what percent of runners do we expect to take longer than 180? If you can find the shaded area, or let me make sure if anyone's like not listening to me. This is what we want. We want that area. We don't want the shaded area. So this one right here is a little bit tougher. It's like a level 5 question on using empirical rule numbers. Bingo, Morgan, you're right. Because think about this. Well, the 2.5 is the shaded area, and then the other side of it's 97.5. Does that make sense, Nikki? 2.5 is this little area, and then the shaded area above it is 97.5. And we want the area above it, like what percent of runners take longer? The ones, yep, no, don't worry, this is the practice. And I did this problem on purpose. If you draw it out, you should see it's a larger area. A lot of students answer 2.5. It's a very common mistake. And I've done it because I'll do the area above or below wrong way. And so it's just the opposite of it, or the complement, I should say. We'll use the complement later. So now we get to a tougher question. What percent of runners do you expect to take between 180 and 210? And let's draw this right here. This is the tougher one. Okay, you ready? Watch this. Let's do this. I'm going to shade an area, and I want you to tell me how much it's worth. How much of the curve has Brian shaded now? How much of the curve has Brian shaded? Oh, you that is the answer. Great job, Nikki, 100 points. The answer is 13.5. If you're wondering how we got that, it's because I've shaded 16%, but then we need to cut off this portion right here. I'm going to try to like super shade this. Do you see how the rainbow pen, I might need to do it in like a red. I need to work on my pens. There's a very similar one. This is like the Canvas content quiz. There's questions that deal with stuff like this. But the Canvas content quiz this today does use empirical rule numbers. If you ever see a question which says use the empirical rule numbers, this is what it's talking about. Does that make sense? When it says use the empirical rule numbers, it's asking you to do this. Like if on the test it says use the empirical rule numbers, the questions will say things like this right here, where it'll make it very, very clear you are using this right here. So make sure if it says use this rule right here, the answers will be from this. You won't be using the applet. So this is why we drew this out right here. We could get better estimates with the applet, but if it says use the empirical rule, the answer to this question would be 13.5. Using the empirical rule, and it's taking these two arrows and subtracting them. And so this is kind of another version, and we'll do the skier question here. I'm going to have redemption on the skier question. We are going to solve the skier question. And thank you, 201, for showing up so much for big questions today. And after the skier question, we are going to do question 2 on 320. I know I keep saying that, but we will. So let's hop over to the skier question. Is everyone doing all right? How are people learning today? It's a good question to ask, right? How do people feel about everything we've been covering? Is it making more sense? Feel free to tell me no, because that's when we delve deeper and we try to make sure we cover everything we can. We're going to do the skier question right here. I think it's question 5 we saw. Oh, it's right here. It's question 1. It's question 1 on the quiz and on the homework. And let's see. Okay, with the skier question, what do we need to do? Well, first off, we're given a mean and we're given a standard deviation. Now, there's a trick to this question. Here's the trick to this question. This is always an exact amount of standard deviations above or below. So just look at this right here. This is 104, this is 4, and this is always an exact amount of standard deviations above or below. So I want you to just think of this as 104, and this is 4. Then what would be, how many standard deviations above is this? So 104, 4, and 8. And so I'm just going to treat those numbers as though they're whole numbers. And so if this is 104, and we have observation of 108 minus mean over standard deviation, 1, exactly. And if you're worried, do the exact mathematics of observation minus mean, and then divide by standard deviation. So the formula I did right there, just so everyone can see, is the formula for the z-score. The formula for the z-score is your observed value minus your mean over your standard deviation. And that'll get you a z-score. A z-score is how many standard deviations an observation is above or below the mean. In context, it's like this. The test had a mean of 80. The test had a mean of 80. The standard deviation on the test was 10. That's like the variation on the curve. Brian scored a 95. Brian's z-score would be what? So the test had a mean of 80. What would be Brian's z-score, as I show this right here visually? Test had a mean of 80. Brian scored a 95. What did Brian score in terms of z-scores? Brian's z-score would be what? Here's your Brian score with a 95. Good job, Brian. And what is Brian's z-score? 1.5 exactly. And if you can see right here in the drawing, Brian is 1.5 standard deviations above the mean, and that's what the z-score means. We are 1.5 standard deviations of the mean. So it's clear, just so you can see the notation. Once again, let's highlight each thing as we do it. This right here is the distances these are away. Each of these is a unit of 10 away. So that's the standard deviation. It's the variance on the curve. It's how much the curve is spread apart. This right here is the center of the curve. It's the mean of the curve. This right here is the observed value. That's what we observed on the curve. So it's telling us how far away this observation is from this in terms of standard deviations. And that's what a z-score is. How many standard deviations is an observation away from the mean? Last but not least, the numbers down below here on the curve are the standard normal curve numbers, all in terms of z-scores. So everything you see right there highlighted is a z-score. So now that we know what z-scores are, let's go back to our problem. Back. Let's do this. So we want right here, according to the normal model, and this is using the 68, 95, 99.7. Can we go over the hard question again? Yeah, we'll do that quick after this, Nikki. You bet. We got it. I'll do one more hard version, and then we are doing some 320. Don't worry, 320, we gotcha. Round to the nearest integer as needed. What is the actual percent of times less than this? So wait, that's the next question. According to the normal model, and we're at a z-score of 1, that's all we need to know. So according to the normal model, according to the empirical rule, and we already have a drawing up for this, I think. So here's our drawing. You know what we can do? Here's what you can do on the test. You can erase your numbers. You can go right here and go 104, 108. And remember, we just rounded the numbers to make the problem easier. It'll work just fine with this version. So I want someone to tell me what percent of area is going to be below 108. What percent of area is below 108? What percent of area is below 108? What percent of area is below 108? Who knows? What percent of area is going to be below 108? Nice job, Nikki. And you always want to try to, like, the more drawings you can do like this, the better practice you get. You can memorize the numbers. Like, I've done this a lot, so I usually know what the answer is like that. But you don't have to memorize the numbers perfectly. But if you can see right here, 16% is above there. Since 16% is above there, then it would be 84% below, because you can go through the numbers right here, and this would create the full arrow. So as long as you know to kind of do this right here, that's the 84, or you could subtract this from 100. That's a quicker way of doing it, to just say, well, 16% is above here, 84% would be below here. Now, this is according to the normal model. Very key right here. I got this wrong in class. Whoops. According to the normal model, like if the normal model is accurate. The next question asks, well, let's talk about the actual data here. So you have to go and find where 108.05 would be. It's right here. How many times are actually above 108.05? 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 I'm going to make sure we reserve at least the last 30 minutes of office hours for 320. How many times are actually above 108.05? How many times are actually above 108.05? Idea? So right here, 4 out of 53. Oh, it says less than. So since it says less than, 4 out of 53 is how many times are above. So 49 out of 53. This is where we make our errors, because it says less than. So does everyone see, if 4 are above out of 53, 49. Great job, Nikki. 100 points, following along. Great practice. And this would be rounded to 2 decimals, 92.45. That's what we get right there. So that is rounding it. Do the two percentages agree? Now, this one is subjective, but here's the hint. They never agree, according to my Pearson. They're kind of close, but the answer is no, because the normal is not appropriate. Don't worry, but people watch these videos. If you look, they get like 100 to 200 views for the office hours. And I always mark what question we're doing throughout these. So if you come back to the video, I'll have a mark in the video where it's like downhill skiing question. Like it'll say like 201 downhill skiing question. So if you don't make it to office hours, you can always see what I did during office hours and be like, oh, that's a 201 question. You can watch like the parts that apply. So even if someone else is here asking questions, it really helps. And just students being here asking questions related to what they're stuck on is a great thing. Nikki, I'm giving you your 1,000 points for a week. I really appreciate just the questions. And sometimes people just don't ask because they're like, well, he's talking about this. So I promised 320, we're going to do it. We're putting the last 30 minutes to 320 right here. But since 201's here and asking questions, and I know they have the big assignment due tonight, that we have that. So this question right here, there's the easy way of doing this and the hard way. The easy way is to kind of look at the data. This data only goes up to what? 117. So you see how this goes up to 122, this goes up to 122, this goes up to 122. Looks like this has the highest data here of 2 observations, or 3. There's 3. Wow, yeah. Look, there's this big gap. Do you see 117, 117, 117, 108, and there's this big gap right here in the data. So you get these 108s right here, and that's the 108s, and they have a gap to 117, and I don't see gaps anywhere on these other histograms. So just by observation, we can tell that this is a very right skew distribution with 3 outliers. So it's a unimodal right skew distribution with outliers, and that is talking about the shape, the center, and the spread. And so the normal model would not be appropriate here. The proper center is going to be median, and the proper spread is going to be IQR due to the skew. So the normal model is not appropriate. It is skewed to the right. The proper measure of center would be median. The proper measure of spread would be IQR. And have we done it? Did we get 100? What did I do wrong? Did I seriously get a decimal rounding wrong? No, because normal. This question is just showing me it is skewed to the right. The data are not normal and skewed right. What did I get wrong, everybody? That's the curve. No, because normal was wrong. Do the two percentages agree? I had to have gotten one of these wrong. Let's see. So what is the number right here? 108. This is less than. Round to the... I see it. You know what, though? If you got this wrong, like I got this wrong, then you could email me and say, hey, Brian, guess what? I really got it correct. So if you got it wrong, like I got it wrong, please email me and just say, hey, Brian, I put in an extra decimal. I will fix that. I just want to make that very, very clear. We did not get that wrong. Not today, my Pearson. We got that correct. We just didn't round it to what my Pearson wanted it to round it to be. Sometimes it wants 2 decimals. Sometimes it wants 1 decimal. I don't know. So, but do not worry. Once again, please email me if that happens to you. A few people have already emailed me today. I go in, I fix it. I can see, like, if you're like, hey, Brian, take a screenshot of it, show me, and be like, here's the question. It says I got wrong, but I put in an extra decimal. You didn't get it wrong. It shouldn't count it. Very sorry about that. The troubles of doing online stuff. Morgan, 100 points. Thank you very much right there. Great job, Morgan. I just did that. I did that to show the example. I didn't, I didn't read the thing incorrectly. Good. Thank you, Morgan. I'm really glad this is, yep, I'm really glad this has been very helpful. That's my goal right here with these office hours, is to walk through problems, explain them, and then help everybody out. That is the goal. Let's see, because can we go over the hard question again? Yes. Okay. So you ready? This is round 2, Nikki and Morgan, of a very hard test question. So let's do this. Brian's going to do this one off the top of his head. Are you ready? So here we go. Canvas, content, quiz, question 3, possible, not real. Okay. Okay, let's do this. So what we're going to do right here is we're going to say, let's go, let's make up something new. So the amount of defects on a car is normally distributed with a mean of, those are usually Poisson distributed. The amount of rainfall in a year, in a month, is normally distributed, it's time series. The amount of, or the heights of students, why not? The heights of students is normally distributed with a mean of, sure, I'm just gonna keep it this one, 68 inches and a standard deviation of 4. We're doing just different numbers, different stuff right here. I'm stating it's normally distributed. You can be like, well, maybe it's bimodal. Yeah, 0. So it's normally distributed with a mean with a mean of 68 and standard deviation of 4. The middle 90% has a z-score of 1.645. What would be the 95th percentile of student heights? Okay, you have everything you need to solve this problem right now. You have everything you need to solve this problem. If you kind of deduce how the numbers could be used, it's a very quick solve. But I would suggest doing a drawing to do this. So what is the first thing we're going to do right here? We know that the 90% has certain z-scores, so let's go ahead and draw our normal curve. So see if you can solve this before I get to the answer. See if you can get the answer. I mean, there's really only a few combinations of ways to use these numbers. I could have asked it in a lot of different ways, but this is a very similar problem right here. This is probably one of the hardest questions we can ask right here. I mean, it varies. Some questions can be hard for different reasons. So what I'm gonna do is I'm gonna draw my normal curve right now to kind of give things context, because making the drawing will at least kind of show me what's going on. And so what I'm gonna do first is I'm gonna put 68 right here. I'm gonna put 72 because each of these goes up by units of the standard deviation. And is that right? Yeah, sure. That's very tall. 64. I did a larger standard deviation than we normally say for heights. So the curve's a little wider than it normally is. So with this right here, what do we see? We see the middle 90% has certain z-scores. So what am I going to do now? I'm going to immediately put in my z-scores of 0, 1, 2, 3. Z-scores always have the same units in terms of standard deviations. So the z-scores right here are just going to be constant units. And then it says the middle 90% has certain z-scores. So I'm going to go right here to where we have a z-score of 1.645. Draw up right here. And negative. And 1.64. Sorry if I didn't make that clear. And now we go right here. And now we're almost to our answer. We're almost seeing what the answer is. What percent is outside of here? If 90% is inside, what percent is outside? If 90% is inside, what percent is outside? If 90% is inside, what percent would be outside? If 90% is inside, what percent would be outside? You got it, you got it. And then that makes 5 on either side. Do you have any guess? And do you see how we can figure out this answer right here? Great job. Great job following along, Nikki and Morgan right there. Do you see how we might kind of know where the 95th percentile is now? Does everyone see that this is where the 95th percentile is. Does that make perfect sense that we found the spot? And then you should be able to tell me with the z-score what it means for the 95th percentile. So we know where the 95th percentile is now, because if you go through this and you go through this, you've made it to the 95th percentile. And the 95th percentile should have, as we see here, 5% above it. So we found the 95th percentile. We know it's right here. Can you just take a guess of what the answer should be? Can you just look at that and take a guess of what the height should be for the 95th percentile? Just a guess. And that's usually what I would say to do, is to take a guess at the answer and then not actually put it as your answer, but just have a decent guess. I would say it should be a little bit more than this, maybe a little bit less than that. What would be your guess of the answer if you just had to guess? I like that right there. That's a good guess. Yep, it's got to be a little bit more than 74, maybe a little bit less than 75, somewhere in that range of 74 to 75. So now that we have a theoretical guess of it, we know what the z-score is. The z-score tells us what? How many watts something is above the mean. It tells us that this is that many standard deviations above the mean, and this is a distance of how many standard deviations. So now we use our formula once again, because remember, it's how many standard deviations. That's what a z-score is. Something is above or below the mean. So if the z-score is negative, it's below the mean. So what do we do right here? We just remember it's just how many standard deviations something is above or below the mean. And so we just take the numbers we have of 1.645 and we times that by 4. We'll do it in parentheses. No. And then we add that to the mean right here. And that'll be our answer. And we've done it. So this is going to give us the answer of where this line is at. Good, that's a good spot right there. So we go 1.645 times that by 4. We add that. Wow. Morgan, you get your 1,000 points for day 2. Your guess was a 10th off. I was actually guessing a little bit higher in my head, but your guess of the answer was actually 800ths off of the answer. So you had an amazing guess right there. And if you use the applet, we would see basically the same answer right here. If we go to where is the 95th percentile on a mean of 68 and a standard deviation of 4, we go to the area below, there's the answer. So you were even closer according to the applet. So you guessed 74.5. And here's the thing you want to see. If your picture right here looks a lot like this picture, so if you look at our picture right here, we'll just make it look just like the other picture to show what we got going on. But amazing work. Really great job today, everybody. 201, doing some great practice. Just sitting down, just working through these things a few times is the way to do it. You just have to do the same problems a few times, be like, okay, I got it down, I know how to do this, and then review before the test. If you look at this graphic right here and this one, look at this graph. All these graphs, same answer. We're doing it with the applet, we're doing it with the coding. Practice makes perfect, you know it, and we're right here at 12:30, perfect time to hop back to the main screener here. Let's see this Wacky Wednesday. Is this Wacky Wednesday? All the time Wacky Wednesday. Take out the pizza. I took out the pizza. Here we are back on the main screen. Let's do this. Is that? I gotta turn up the lights again. I don't know if you see that green screen. It's not. I'm not on the green screen. I'm in the future. That's where I'm at. Let's bring up Sakura. If you're still here, we're gonna do some 320. If you're not, definitely check out the video later. But you asked, and we are gonna do some 320 as promised. Great work. I just want to say great work. It really. I don't know. I know a bunch of people have been working on these assignments really hard for 201. The normal curve is, I would say, one of the first big challenging chapters. Some chapters are easier after this. It won't stay at this level of difficulty. Every chapter won't be like the normal curve, but the normal curve is definitely one of the chapters where I see people getting stuck. And I appreciate everybody being like, I have to take some time. I have to work on this. And that's why we've definitely given more time and everything just to make sure people get the practice they need. And so we are ready to go here. Reopen, close PDFs. No, we're good. Okay, I think we're good to go. We're going to hop back. You're welcome. You're welcome, Nikki and Morgan. Great work. Let's go back to the main screen on these Wacky Wednesdays. Bring us over there, Crash. I'll fix the green screen. Sorry, Crash. Don't be sad. Wacky Wednesdays. Let's do this. So we have the homework packet right here for 320. And let's go ahead. Oh, great. Look at this. All this good stuff right here telling us what to visualize. We see the chi-square distribution, which we mentioned. Just got to say the online Z-calculator made this seamless. Exactly, Jacob. I think I might have told the story. Jacob, 100 points for being here, saying, hey, I might have told the story that my brother was doing some of this for his statistics class, and he was using a Z table, and I was like, dude, don't do that. Don't use the Z table. See you in class, Jacob. Awesome to have you here. Thank you for, I guess you were watching and everything, and kind of awesome. I love that some people are watching during office hours, learning. I love it. And so the online calculators make it so easy, and you can actually, for the 320 474 students, and that's a fake ID right there, you can actually go here and you can actually do Q norm, and this will give you quantiles on the normal curve. So you could go here and enter like the 97.5th and you'll get 1.96. So you could actually solve the problems using the R Studio if you want. You could do P norm, and so this will get us right here. If we do P norm, this should get us the area below 2, which should be 97.5, or we could do 1.96, and that'll be 97.5. So you can use RStudio to solve these problems too. So there's a lot of ways to do it rather than looking at a Z table. You can get exact answers. If you notice, this carries out even more decimals for you, which is really awesome. 1.599. Oh, is that even further off? Is it? It's got to be even higher then, right? So what's the next decimal? Is it 8? Sorry, this is my own personal wanting to know. If Connor's here, he's probably interested in this too. Connor usually like Connor, here's the actual Z-score for the top 2.5% down to that many decimals. There's things I care about, and that's one of those things. So it's 1.959974, because if you use 1.9599, you're actually more off than 1.96. No wonder 1.96 is so classic. Enough about that. Let's talk about this problem right here. So this problem is one of the ones for 320. It's dealing with bivariate categorical data. So when we deal with bivariate categorical data right here, we get a contingency table. From a contingency table, we can make a mosaic plot. And so one of these ways I'm going to deal with this data is to actually go to the actual data set it's from. It doesn't tell you this in the problem, but I'm going to go and use the data, and let's take a look. So this data set, if you want to use it, is from the stat survey. You have to go here to library, which pulls up the libraries, which are things we can use. And then we're going to go to data survey 09. In data survey 09, you have gender, and you see there's 579. Just to show you again, there are 579 observations in this data table. So we have the 579 observations, and we also have gender right here, and then we have sitting location, which is X12. I'm going to do another additional step, which really helps us out, and go to attach survey 09, and this will attach it. So I can type things like X02, and it'll give me gender right here, and I can view gender. I can type X11, and we get, or X12, and I get sitting location. So these are the sitting locations of the students and also of their gender. So one of the easiest ways to deal with this problem is to do the following. I shouldn't do it. I'm going to do this problem just to help out, and so people might see us during office hours, but this makes it really easy. We're going to do this the easy way, and then we're going to do it the harder way. So here's the easiest way to deal with the problem, a function called associate. And if you don't see that you have associate, it's because you don't have reg class on. You have to make sure reg class is running by running library reg class, and then you have the associate function. So with the associate function, we want to see if there's association between somebody's sitting location and their gender. Please do not include things like these, or you will just flood your output. You will flood your report. So be very careful if you include things like I'm doing. I often do things to check, and I'm often not knitting. I'm just like doing work and computing things. But if you're going to knit something, you only want to include the output that's relevant. I can't state that enough. Like only, I'm going to put it here, like only include relevant output. Do not include too much output. I can't state that enough. Like if you're watching this, watch what you output. Look at it after you knit. Let's put that here. Look at what you knit. So look at what you knit. Make sure it's what you want to knit. Like make sure it puts out the right output. You can always delete stuff after you knit. Let's put that here. You can always delete from Word. If you see tons of pages of stuff, you can just delete them. I've had people turn in 1,000 page documents. That's not a joke. I've had people turn in literal 1,000 page documents, and it'll crash the reader and stuff like that. So you get a 0. I'm sorry. Don't let that be you. Don't let that be you. Okay. So we've got these important notes right here. Let's show how this function works right here. Data equals, and data is equal to survey 09. So the format for this code is as follows. The format for this is y tilde x comma data equals and your data. Now the tilde button, I always knock something over when I do that. The tilde button is this button right here on my glowy keyboard. It is that right below the escape. So I'm on the far end of the keyboard. That's the tilde button. I don't know. I think it was my pen. Okay. Don't want to unplug monitors. Watch out. So that's the tilde button right there. Y tilde x comma data equals. This is just a note for us how to use it. So I'm commenting it out using the shortcut Control Shift C. So now we're going to run this code right here, and it's going to run all the associations for us. And it's actually going to make the mosaic plot, and the permutation test down below. It also made, which I wanted to say next, the contingency table. The contingency table and the mosaic plots are two displays of categorical data. So notice here you have the graphical display of categorical data, and you have the kind of numeric display. When we look at this 126, which are females who sit in the middle, it represents this right here. When we look at this box right here, this is females who sit in a varies, and varies where they sit. So that's 14 people right here. Oh my gosh. Brian was looking in the wrong spot. This is the females right here. I noticed there were more females than males. Here's the females. There's the 14 females. That was 10 males right there. See, we all make mistakes. So there's 10 males right here, that blue area. And then this green area was the 106 males. That's the green area right here. And then this area right here is the females. You notice how we're within the females column right here. So this is a conditional distribution. Keywords are being stated right now, like the conditional distribution or the marginal distribution, and these do apply to 201. So if you're still watching this from 201, we obviously cover these concepts again, and we can do these things really quickly. If you notice, I wrote one line of code, and it gave me all of this output. It produced so much for me. So with this output right here, you can actually see we have the expected counts. The expected counts are the row total times column total over grand total. So if you go here to this column right here, we need to do row total times column total over grand total. Let me show how we would calculate. Let me do this real quick. And let's show how we do one of the calculations to show how to calculate an expected count. An expected count would be the following mathematics. The expected count is row total times column total over grand total. So let's say I want to say, how many males do we expect to sit in the back? So males do we expect to sit in the back? I go row total times the column total over the grand total. That is the literal formula, as in like 107 times 250 over 579. Let's check our mathematics here. 107 times 250. Oh my gosh. 107 times 250. Calculator's trolling me. Stop it. Divide by... Really? Last try, calculator. Not today, calculator. Okay, we're going to do it. We're going to beat the calculator. We got this. There we go. 46.20 right here. That is 107 times 250 over 579. And let's check to see if we got those results inside of R. And if you look right here, the answer is 46.2. And that is the answer we got for the males right here. Males who sit in the back. And that is that. It solves all of them for you. So you could find a specific one you want. It's important to know how to do this formula right here to find the expected. It's just row total times column total over grand total, as in the row total for males, the column total for back, and then over the grand total, which is always the same. Now from this, we can get the cell chi-squareds, which I'm thinking that is not on here, but we could calculate a cell chi-squared. I'll show how to calculate that. That is observed minus expected squared over expected. And let me write that formula so everyone can see what I just said. The formula is observed, whatever we observe for that cell, minus the expected, which we just calculated, squared over the expected. And that is a discrepancy, or also more classically, a cell chi-squared. And we are going to take, for the cell we observed, it was 45 we observed, and I'll show you really quickly here. Does everyone see we observe 45, we expect 46.2. So we do observed minus expected, we square this value to make it positive, and then we divide by the expected. That is the cell chi-squared. Now, each of these cells will have a cell chi-squared. So every one of these right here, because they all have expecteds, will have a cell chi-squared. We take all of the cell chi-squareds and we add them up to get the chi-squared test statistic, which here is called the discrepancy. And that's kind of the overall discrepancy. From the overall discrepancy, we plot it on the permutation results. So we're covering a lot of topics very quickly right here. Please slow me down for 320. But this is kind of the steps we get to finding the p-value. If you notice that that discrepancy right there was 102 or 101 point something, it's plotted right here on the red line. And we talked about this a lot at the end of class yesterday. So this 101 right here is our observed discrepancy. And then we want to know what percent of results are as extreme or more extreme than our results happening by random chance. The permutations here are random chance occurrences. So each one of these is a random chance occurrence. To show this right here, let's do this. Let's go right here and make our code look a little nicer. And let's add another argument. So I want you to think about how these p-values are being calculated. The p-value here, let's look at this result, is 60%. And I need to vanish for this. The p-value here is 60% because there's 5 permutations. A permutation is us taking the data and mixing it up. You are right, David. It's not statistically significant. Just to answer David's question, this is not statistically significant. Its p-value for the result was around 80%. Where's that result? Great question. It's basically 80%, and that's the area above this red line. The percent of results that are as extreme or more extreme than our results is way more. Does that help you with that question, David? Because that's one of the questions for this. The percent area above this is way more than 5% or 0.05. Which is 5% on the curve. So it's way more than 5%. It is not statistically significant. Does that help with that, David? Thank you, David. 100 points, David, for being here and asking that question. I was like, I'm going so quickly. I was like, uh-oh, I hope I'm not losing anybody. But with these permutation results we're seeing right here, does it make sense, David, why right here, if there's only 5 permutations, only 3 out of the 5 random results were as extreme or more extreme than ours? Only 3 out of the 5. And this is our result. And the percent of results that were as extreme or more extreme than our results was 60%. So if you do the following, what is the p-value here? Exactly. Does this make sense why the p-value here is 40%? So the p-value here is 40% because 40% of those results are as extreme or more extreme than ours. What right here, what would be the p-value here? What percent of the results now are as extreme or more extreme than our result? And you remember, our result is always going to be at 1.01, 1.016, and now it's 100% of the results. Exactly. So you can see how the p-value is being calculated. Another one, and this is 80% because 80% of the results. So if you increase the permutations, you're going to see more lines on the curve. So we can increase the permutations, and now you have 1, 2, 3, 4, so that's 80%. 4 out of 20, or 16 out of 20 is above it. And here there should be 5 results. 1, 2, 3, 4, 5, meaning 15 above. I know, it's so cool, right? And then all we're doing is we're just making more and more permutations to where you could just keep making more and more permutations and get a better estimate of the p-value by just doing random calculations of what would happen by random chance. And it looks like our result is what by random chance? Like likely or unlikely by, classically, random chance. Our result right here looks likely or unlikely by random chance. Like the discrepancy we observed would be what by random, very likely. Exactly, David. Great job right there. What is the smallest possible discrepancy, and how would this graphic look if it had no discrepancies? The smallest possible discrepancy we could observe, the smallest possible discrepancy, would be a discrepancy of what? The smallest possible discrepancy would be a discrepancy of what? Smallest possible discrepancy would be a discrepancy of what? 0, exactly. 0 would mean all of the observed were the expecteds, and you would have this right here. You would have it match up perfectly. So that one I have highlighted right there has a 0 discrepancy. It has no discrepancy at all. And if you look right here, this one has a much larger discrepancy, which would have a smaller p-value. So to kind of talk about these right here, if you did the permutations of this one, these would, both permutation results might look exactly the same. Like both permutation results of like mixing up the data might look the same. Like if you mix up the data and see what could happen by random chance, you'll get very similar like distributions of like what would happen if you randomly permutated this data. But this one right here is going to have a line right here, and its p-value is going to be what? This one here would have a p-value here, and this one's going to have a p-value all the way over here. Am I not blocking it yet? So in graphic A, we have a discrepancy of 0, and the p-value is going to be what? Meaning that what we observed was very what? So in graphic A, there's no, Yep, exactly. Yep, bingo. That's exactly what I'm getting at. So this one right here has like a near, like there's basically, this is like totally improbable by random chance. So think about this. We're saying this discrepancy right here, this kind of gap in this data is so unlikely by random chance that we think there's an association. To bring it back to the chapter, we think there's an association between, I always use like tests, like if you take test A versus test B, and if you pass versus you fail. So in this one right here, we would say like, there's strong evidence of an association. In graphic B, we got to change these numbers now. So we got to do this 1 and 2. So in graphic 1, there's no association between the test someone takes. Any differences we see are likely by random chance. You could change this a little bit right here and make it a very small gap and do something like this. Now there is a discrepancy. There's a little bit of a discrepancy, but the discrepancy is so small that we would say, okay, it looks like the differences we're seeing between people's tests on whether they pass or fail is likely by random chance, because there is a small discrepancy here. It's not a zero discrepancy, but we would say that the discrepancy is small enough that we think it's by random chance. It looks likely that the discrepancy we observed is merely due to random chance. Is that making, and then in graphic 2, the discrepancy is so large that we would say it's unlikely due to the p-value that it's by random chance. Is this bringing it together for you, David? How we get these p-values and we say like, oh, this is not likely by random chance. The permutation thing is a big thing that I think people usually struggle with. Hopefully we've clarified that. My hair's just getting crazy. Makes total, oh man, David, I love hearing that. Like hearing makes total sense. I get what's going on right here. In graphic 1, we have a small difference that is totally likely by random chance. Because imagine if people complain to me, what would I say to students if someone said, well, I took exam B and more people failed it? I'd be like, well, yeah, more people failed exam B, but due to natural sampling variation of who takes the test, the differences we see in the pass fail rate could just be random chance. Like there's no good evidence that more people fail test B, that it's associated with failing the test. It could just be that, hey, 2 more people failed it out of 1,000 people. Yeah, more people failed it, but the differences we observe might just be due to random chance variation between who takes which test. But then if you go over here where we see something like 10% of people failing test A and 60% of people failing test B, and students are like, yeah, I heard everyone failed test B, I'd be like, they'd be right. They'd be like, well, that difference is so large. And we better be careful when we say so large. It would be so unlikely, we should say. Because what if this was only for like 10 students? Well, because like 5 students here and 5 students there. You have to have a large enough sample size to be able to detect statistical significance. And that relates to the power of a test. The large enough sample size relates to power. So hopefully this makes a lot of sense right here. Trying to think what else. I think the other questions aren't so bad on here. That's some of the harder stuff on question 2. It asks things like how many males sit in the front. I think that should be kind of obvious. It's just looking at a cell right there. Report the marginal distribution. There are 2 marginal distributions on here. So if you want to report a marginal distribution, give the percentages. Here's one marginal distribution, probably an important one. And here's another marginal distribution right here. Here's another marginal distribution. So the marginal distributions are always in the margins. If you're looking for a marginal distribution, look for the margin. So this is the marginal distribution of gender, and this is the marginal distribution of where people sit. And then a conditional distribution is within one of the X variables. And we're seeing if someone's gender explains where they sit. So that would be the conditional distribution for females, and this would be the conditional distribution for males. So you'd have to go here and divide like 45 by 250, which is going to be like 8. What is it? No, it's exactly that, isn't it? I think it's 18%. Nicholas, checking out those points right there. Nicholas, great work. Mubot, what do you have to tell us? And Nick and David, do you have any additional questions? I might turn on the air conditioner a little bit more. It feels a little hot in here today. What's Mubot? Mubot. Oh, that's awesome, Nicholas. I'm so glad to hear that. I enjoy it too. I'm working on something, but I think I can only do it if I stream via OBS. Do you want to hear what I'm working on, Nicholas? And then, I don't know, if you'll have more questions, feel free to ask. I might just mention this and we'll be ending soon here. If you go over 2 hours on YouTube, it actually does a weird thing where the stream doesn't upload as well. Folding laundry while you do. That's awesome, Nicholas. That's awesome. That's what I do. I usually put something on in the background, be like, I'm just going to chill to this. If you play Smash Bros, it does like an intro. And it's like da 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 da. It's like so and so enters the battle. What I want to do is create like you can do it in OBS, but I don't think Streamlabs has the plugin. I haven't found it yet to do it with Streamlabs. But in OBS, you can. I know, right? In OBS, like you can freeze frame. You can like click a button. Except for question 3 needs to stay. Yeah, no. Let's do question 3. Let's do that here. I'll mention this. Then David, you got it. And ask what part are you working on question 3. I'll go to that next. I bet I could get my fiance to let us play it one time. It's such an amazing piece of music, orchestral and everything. We'll do this one next here, David. So what I want to do is like I want to be like this or something, and then in OBS you can freeze the camera, and then I could create some effects that like blurs around me and stuff like this, and I could make the screen go like all anime like with like things flying across the screen, and it could say like like Statman, or I don't know. It could say Brian Stevens for all purposes. But it could say Brian Stevens enters the battle. You better know your statistics or something. Like, because it always has a little tagline for whoever enters the battle. But I can do it in OBS. And I'm like, okay, does that mean I got to switch to OBS to do like one effect that I want to do? And so, I don't know. I think it'd be really cool. Like if I just hit a button, but see, I need to, or maybe it would pause in 5 seconds. I could set a delay on it. So I could hit the button. I could be like, like this, and it would freeze the screen and be like do 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 do. So that's my idea that I had, and I could do it if I did it in OBS. Anyways, so here's the question right here. Which part of this were you wondering about, Nick? Feel free to ask which question specifically. This is us analyzing the variation. This is one of the big reasons I wanted to push back the assignment, because we really haven't talked about a quantitative Y right here and a categorical X. So Stat Tool 1 has actually talked about this a little bit. This is the association right here where we analyze side-by-side box plots. Yeah, I know, Nick, it'd be so cool. Like, I can do it if I stream via OBS. Like, maybe I'll do like one stream via OBS, and everyone will be like, that's the best effect ever, do it again. So, need to put like a countdown appears on my thing. I could like see it. So we have here a quantitative Y and a categorical X. Should notice the difference here. Well, we don't have a mosaic plot on here. Mosaic plots are categorical. Don't listen to me. Mosaic plots are categorical. Scatter plots are quantitative. So just so you can see what a scatter plot looks like. Here is a quantitative relationship. That's a quantitative relationship, bivariate quantitative scatter plot, mosaic plot, bivariate categorical. And then if you have a quantitative Y with a categorical X, you're looking at side-by-side box plots. So which thing, David, were you wondering about here? We can do, well, you see, here's the interesting thing. Look at this. This looks very similar to what we did before. And it says an F of 4.7. It's almost like we should go here and drop a line at about where 4.7 would be. And David, can you see the p-value? Can you see the p-value? Because this is below is the 4.7f, which sounds a lot like a discrepancy. It sounds like we're kind of doing the same thing as we did above here, where we drop the line right here and we shade to the right. And that's the p-value under the curve. Ah, very careful. Yes. Kind of the two classic answers in statistics of either 0 or 1, or pretty much any mathematics classes. Like a good guess is usually 0 or 1. Probably 0 is probably the best guess. And it does happen to be 0 here, because there's no results as extreme or more extreme. So is this statistically significant, David? If you look, there's 0% of results due to random permutations that occur that are as extreme or more extreme than ours, meaning ours was, 100%. You got it, David. No need to call me sir, don't worry. I'll pure be nice. I don't mind. It just makes me feel old sometimes. See, I shaved today. Now I should have people guess my age. And everyone be like, 20. I'd be like, yes, you got it. And then I go get to buy a drink, and they're like, you can't. We heard you say online you're 20. We heard you say that you're 20. Whatever we hear on the internet is true. That's a true statement. So the F statistic right here is 4.7. This right here, I'll show it and I'll basically explain it. So I'm kind of giving it away, but it's important we know what the F statistic means. The F statistic right here in this context is a ratio of what we observe over what we expect. So here's the way to think about the F statistic, and this is what I'll probably talk about in class. So I always pick two people. This is my classic example. I have examples I've come up with over semesters. So David, I am going to pay you $10 an hour to do grading for me. Got that, David? I'm going to pay you $10 an hour. So would that be what you observe getting paid or what you expect to get paid right now? I'm going to pay you $10 an hour. Is that what you observe getting paid or expect to get paid? When do we say what you expect? You're right. So you expect $10 an hour. And then, at the end of the semester, I'm like, David, I'm sorry I didn't pay you. I got behind. I'm going to pay you $80 an hour. I pay you $80. So that would be what you observe. We'll put it this way. So you observe getting paid 80. What is your F ratio, David? What is your F ratio right now? Can you calculate your F ratio right here? Can you calculate? Bingo, it's 8. Because if we take these numbers, we can get the ratio right here, which tells us you observed 8 times more pay than you would have expected. So when we think about this in context right here, what this means for observed and expected with this data is that the variation between the groups is 4.7 times larger than we would have expected, like the observed variation. Remember, O goes on top. O is the observed one. So the variation we observed between the groups is 4.7 times larger than we would have expected. Does that make sense? Like, we are observing 4.7 times more variation than we would have expected. So we don't have to worry about the exact numbers right here. We don't have to worry about if this was like 10 and this was 2, because that's about 5. Like maybe, I guess, so this would be 9.4. So it'd be something like 9.4 is what we observed and 2 is what we expected. And then thus 4.7 is the F statistic right here. So it'd be calculated via that. It's more important, rather than calculating it, knowing the practical significance here that this 4.7 represents the variation between the groups, which if you zoom in right here, you can see there is variation between the groups, rather small. I mean, it's in units of hundreds. Changes in demands of about 100 or so is not that small. It doesn't reach 1,000 though. If you go to 1,000 right here, the groups do not vary by more than 1,000. Hint for another question. But there is variation between the groups if you look between the means, or medians, these are medians. Very, very clear on box plots that these are medians. So the variation between the medians is about 4.7 times larger than we would have expected due to random chance. And that is statistically significant. So that is pretty statistically significant. And what might suggest that there's an association? Any information, like if I told you it was this day of the month, what day of the month has the most variation in demand? So if I told you it was this day of the month, you might think, oh, that's got a lot of variation. Like, I mean, that's like the highest and lowest days of the month for our demand for these bikes. So like what day of the month? Saturday, exactly. So if you know it's Saturday, you know there's more variation. And then if you know it's Tuesday, you know it's more consistent. If you know it's what day of the week is the lowest, if it's Monday, that's generally lower and our highs are not as high. So any sort of variation on, between the box plots is an association. Now, the association here is not that strong. There's not like a really strong association. Just to show you right here, a very, very ridiculously strong association. It's like if I look at the grades, so we're back to test scores right here. We'll go like 1 or 2 more minutes. That's such a bad idea because if I go over 2 hours, the screen goes nuts. I'll just wait to put the timestamps until way later. Okay, so here is box plot group 1. And here is box plot group 2. Okay, here's box plot 1. Here's box plot group 2. And these are test scores. So we'll put right here the same scale. This is 80. This is 90. This is 100. And these go across. That's 70. And this is 60. Okay, cool. So when you look at the first group of box plots right here, and the scale goes across all the data. So if you look at the first group of box plots, these differences on these box plots here look to be due to what? If you were to look at the differences between those box plots, they look very small and likely due to what? Like, I mean, there's really even next to no observed differences. The differences between those box plots are very small and likely due to random chance. So the F statistic right here might actually be below 1. The F might be something like 0.7, which tells us the variation between the groups was about 70% of what we expected. There's even less variation in that than we would have expected. Does that make sense? By random chance, we actually expect more variation than that. Like, those look so similar that it's like, well, there's nothing going on there. It's like, take test A, take test B. I don't really see any difference between the scores between A and B, and it looks like any differences are very likely by random chance. Now we get the same sort of permutation graphic right here, but on this one, and am I off the screen? I am. On this one, our results are probably so far away that it wouldn't do justice. I'm trying to do justice right here. But if you notice the p-value here to kind of bring it back to the other examples, the F statistic is going to be so large, and the F statistic is the ratio of the variation we observe between the groups to what we would have expected, and maybe it's something like 12, telling us that there is 12 times the variation between the groups via what we would have expected. So there's a lot of variation between the groups here, and that's what the F is relating it to. This one, there's very little to no variation. Apparently there is some variation because the F is not 0. I guess I could technically say, because I kind of drew it that way, that the F is 0 right here because there's no variation. So if there was absolutely no variation, the F would be 0 and the p-value would be 1, to kind of do some extreme examples. How does this look, David? Does this make sense of this topic right here, how we're using the same permutation procedure right here, and it can then calculate the probability of observing this such of a discrepancy? And you can call an F a discrepancy. And so do you see how this is like the variation between the groups, just like we have the discrepancies we have over here? Just look at the similarities between these two right here. Classically, you knew it was coming right there. So here we are with this one, and here we are with this one, where you can see this has, the left one has no variation, and thus the discrepancy is very small. The right one has lots of variation. The discrepancy is very large, and the p-value is very small. Same thing with this one. There is 0 to no discrepancy here. It's a very small discrepancy, which is likely by random chance. And I guess we could just add in the last bit of notes here. This has a discrepancy. These are all estimates equal to, let's say, 1. And this has a discrepancy equal to, let's say, 12. Those are just estimates. If anyone's watching, you're like, how'd you find that? I'm just kind of making it up. I'm saying like, oh, that's a very large one. That's a very small one. And what is large or small? Large or small is denoted by the p-value, and the p-value is found via the permutation procedure. Make sure to review these, ask questions. These are the complex things. If you get them down, then you understand it. Somehow I got some blue light today. It's because of saturation. I don't know. Any other last questions before we head off here? Really good office hours today. Lots of really good review. 201, 320. We started really strong with 201. We ended strong with 320. 474. We got you next sometime. But I think that's got it. If that's done it, do we have a certain outro people want? If you're here right now, be like, Brian, play this outro. You're welcome, David. Do we want the everything is fine outro? In honor of 201. Oh, Sakura, I'm so glad to hear that. I was hoping you're still here. But yes, there's the points. Amazing work, everybody. I need to enter in everyone's full. People might just get enough points by watching the channel. Like we're a third the way through, and those are points just from like watching. You might get enough points just literally by watching. Dealer's choice. I created this one. It's the everything is fine. So I put a bunch of work into this. So we're gonna watch it here, and maybe one of these days I'll play the Smash Bros. One that I made this weekend. I'm just too afraid of Nintendo coming after us. Amazing points. Amazing. Look at this. Not to flex, but because I'm here all the time. That's because I'm here. So there you go. There's a reference point. I might have changed my points though. I might change my points. Yeah, I've got a Smash Bros. One. It's on the Discord. If you go to the general chat on the Discord, I posted it on the Discord. So go look at the Discord, and I made a Smash Bros. It's a lower quality version of it because you can only upload like 8 meg files. But I'm just afraid Nintendo will like hit us with a copyright. I know I got full credit, and so I think I changed my. No, that might just be because I was seeing if it would change. That's got it. Let's do it. Let's end with everything is fine. Here we go. I will see everybody in class 201. I'll be seeing you in a little bit. 32464. I'll see you tomorrow. Bye.